So here we are, the last item on our agenda, which is graphing probability distributions. And a graph for a probability distribution is going to look a lot like a graph for a frequency distribution. And specifically, we're going to look at our probability distribution for the number of heads, and as we said before, it looks like this. So your probability distribution for number of heads, the possible values you can have out of two coin flips, 0 heads, 1 heads, or 2 heads, and then the probability of getting each one is 0.25, 0.5, and 0.25. So just like you could take a frequency distribution and turn it into a histogram, you can take a probability distribution and turn it into a graphed probability distribution. And we're going to do something similar here. So on our x-axis, we're going to write out the possible values that our variable can take on. So here our variable is number of heads. And so the variable consists of these different possible outcomes that we have, and the outcomes are 0, 1, and 2. On the y-axis now, instead of counting frequencies, we're going to graph the probability of each one occurring. And here I'm going to make one line for 0.25 and one line for 0.5, since those are the different probabilities that we're talking about here. So to make this graph, you're going to do this very similarly to what you would do if you were turning a frequency distribution into a histogram. So we're going to look here for 0 heads, and we'll see we've got a probability of 0.25. So a 25% chance that if you flip a coin twice, you're going to get no heads at all. So we're going to draw a line from, draw a bar going vertically up from 0 heads, it'll go to 0.25. Here we're going to see for getting 1 heads, there's a probability of 0.5, so we're going to draw a bar going up from 1 heads to 0.5. And then last but not least, we're going to say for 2 heads, we have a probability of 0.25, so we're going to draw a bar going to 0.25 as well. And on this side, we're going to label this probability. So that's it, we've graphed it. You've got your different outcomes, which we can also think of as a variable values on your x-axis, and you have your probabilities on your y-axis. And so just at a glance, you can see that our greatest probability is for 1 heads. That's the most likely outcome you have when you flip a coin twice. So I also mentioned thinking about the graph as having an area. So when I say an area, I mean like a shape. So, squares have area. And for these, I want you to imagine that each bar has an area equal to its height. So we're going to say that this bar has an area equal to 0.25. This bar has an area equal to 0.25, and this bar has an area equal to 0.25. And if you think about it that way, you'd say that all this area in the graph adds up to 1. So 0.25 plus 0.5 plus 0.25 adds up to 1. So we're going to say the bars add up to 1. And this is always going to be the case when you graph a probability distribution. So when we look at this one, there's not a whole lot to do with that information, but this is something else that's going to come up again. So just keep in mind when you graph a probability distribution, the area of that graph, if you think of each bar as having an area that's equal to its probability, it's always going to add up to an area of 1 for the graph. So I'm going to leave you guys with that for now. Problem set as usual. Ask me if you have any questions, and otherwise, have a good week.